Good morning, one and all. This is Dr. Diana. Welcome to session 7 on modern software engineering. We have been looking into so many development aspects in agile methodologies, including incremental requirements, customer tests, test-driven approach, its cycle, refactoring, and we moved on into incremental design and spike solutions. Now is the time to deliver our software after researching and after all the development phases. Now, before we deliver to the client, we are going to check or improve the performance before it is delivered. So we will be looking into what performance optimization is, how we go about it, and how exactly is performance measured in agile environments, and how to deliver an optimized performing software. When we look into optimization, there are so many aspects that are underlying that influence the performance of a particular software. So we will look into this optimization as a process that we do only when there is a proven need. So we are not going to optimize anything and everything. Optimize only when there is a proven need. Otherwise, optimization might be a very, very expensive process. Now, most of our optimization parameters will always include analysis of the cache memory. If our cache is good enough, our performance will be good enough. With that idea in mind, cache coherency requires that the data in the cache changes when the data in the underlying storage changes, and the vice versa. But it's easy to get wrong. Reading a single line from a file from a disk requires coordination of the CPU, the kernel, the virtual file system, a system bus, the hard drive controller, the hard drive cache, the OS buffers, the system memory, and the scheduling pipelines. Now, when all of these systems are at work to fetch just one line of code, if our performance fails, where from do we start optimizing? Each of these components are existing to solve a particular problem, and each of them has certain tricks to squeeze out the performance in there. So it's the testers and the developers' responsibility to check if whatever we are trying to accomplish using the software is perfectly optimized at each of these levels as the data is being passed around. It is not possible to exhaustively identify where the performance is lacking. So a holistic approach is the only accurate way to optimize such complex systems. The measure of a performance of the entire system, through that we can make some educated guess about where to change, what to change. So once we try changing that, we'll have to remeasure the performance. If the performance gets better, then keep the change. If it doesn't, discard. For example, in certain systems where the RAM is very small and you have a very intensive graphic application, if you add some RAM component to it, your performance might improve. But for a very simple program that's running on C or Java, requires or has a latency, will the same solution of adding a RAM component will work? It might not. So what you do is you make a change to the system, identify if the performance gets better. If it gets better, keep the change. If not, discard the change. In our example, for the graphic application, when we add the RAM card, it gets better. So you add the RAM card, keep it that way so that your performance is better. If not, discard the RAM card. For the Java application, if we do not want that RAM card, remove it. It still works the same. So you can even rule out your possibility or options of whether that is the particular solution or not. Once your performance test passes, you are done, or more like optimized your software. look for any refactoring opportunities and run your test suite one more time. So if at all there is some refactoring possible, do it and then check and remeasure your performance metrics once again, and then you start integrating your modules. And integration might even give you more avenues for exploring your performance. Now, optimization has two major drawbacks. It often leads to a very complex code, and while improving the optimization, it takes a lot of time from delivering your deliverables to the customers. Both of them are not liked by the customers. So when both the aspects of optimization are not needed by the customers, we stick on to our motto that the optimization is required and it is used only when it serves a real and a measurable need. Unless you don't have that measurable need, don't go in for optimization. And do testers really have an impact on the performance of the system? How exactly do they influence the performance? When we work with dedicated testers, they often act as technical investigators for the team. One of the ways they do this is to investigate non-functional requirements such as parafunctional requirements and also the performance. Testers should help customers articulate their non-functional requirements, then create and maintain test suites that evaluate the software's ability to meet those requirements. So the testers are supposed to have a set of test suites that evaluate the performance of your system. These test suites can test the stability as well as the performance, and also check how well the systems are scalable. Now, after you do all this, you have a system that is scalable, that has a very high efficiency in its performance, and that is delivered fast. So with this, we have understood how performance optimization works in agile methodologies. Meet you in the next session. This is Dr. Diana signing off.